Hey everyone, it's that math magician, and on this video, we're going to continue looking at exponential expressions, and we're going to start to develop and understand what the laws of exponents are. Hopefully in the past videos, you started to see and recognize these patterns emerge when we're expanding and simplifying. And what we're going to do is we're going to look at those different patterns and see, can we generalize them into certain laws? Let's start off with this first example here. X to the 7th power times x to the 4th power. Now normally we would expand, we would write all the terms out, and then we would simplify. But I want you instead to just think about what would happen during that expansion. I would write my 7x's here, multiplying my 4x's here, and then what we would do is we would count the 7x's, we would count the 4x's, and we would end up with our term as x to the 11th power. Are we starting to realize that when I'm multiplying my exponents in this way, where I have my base with the exponent, multiplying my same base with the exponent, that all I'm doing with those exponents is that I'm adding them. I'm just writing out the 7x's, I'm writing the 4x's out, then I combine the 7 and the 4, and we get 11. So the first law of exponents that we have is that if I have, let's say, x to the m power times x to the n power, and what the m and n are representing, they're just representing any numbers. If I have a problem where I see this occurring, instead of needing to expand and to simplify, we now know all we have to do is take those exponents, the m and the n, and we just need to add them. Okay, we just need to add them because when we expand and simplify, that's what we're doing. Okay, that is our first law of exponents. Let's go ahead now and look at our second law. Now our second law is going to talk about these division problems we've been seeing occur. Let's say that I had x to the 20th power over x to the 15th power. Now again, what I want you to think about is, imagine that we actually wrote this out, and we wrote all of the x's multiplying on the top, and we wrote all of the x's on the bottom multiplying out. And then think about what happens as we start to cancel those through. Hopefully we can start to understand that if I have 20 on the top and I have 15 on the bottom, since 15 here is on the bottom, I'll be able to cancel 15 of the x's that are on the top of this fraction, that all I'm going to be left with is x to the 5th power on the top. All of the other x's on the bottom have been removed. We've taken 15 away from that 20, and that's moving us again to this generalization that if I have an exponential expression and it's a fraction, and I have two bases that are the same with exponents, all we really need to do is subtract the numerator's exponent from the denominator's exponent. Okay, so I just have to do 20 minus the 15, and we get the 5. All right, let's go ahead and generalize this over here on this side. If I have x to the m over x to the n, all this is going to do is I just need to take those exponents and I just need to subtract them out. Okay, that is our second law of exponents. Okay, this is a quicker shortcut. Instead of having to expand them all out, then start to canceling all the ones that are on the top and the bottom, we can bypass that now and just know that we have to subtract them out. Let's look at our third law of exponent. Our third law of exponent comes from an expression that looks just like this, where we say we have x to the 4th power, and that is going to be a quantity being cubed. Now, again, I want you to think about this. If I were to expand this out, we would have x to the 4th times x to the 4th times x to the 4th, right? And once it looks like this, we know that that looks like our first law, and that all I really need to do is I just really need to add up all of those exponents there, right? 4 plus the 4 plus the 4. So what that turns into is it turns into x to the 12th power. But again, I want to see, is there a shortcut that we can see so that I don't have to expand it out anymore? Hopefully we can start to notice that the 4 and the 3 there, how I'm getting to this 12 is that I'm just multiplying those two exponents together. Okay? Because I have 3 sets of 4 x's, I'm just doing 3 times 4, which gives me that 12. Let's go ahead and generalize this one as well. We're going to have x to the m power to the n power. If that ever pops up for you, all you have to do is take those exponents and you're going to just multiply them. M times n. Alright guys, these are the first 3 laws of exponents. We have 2 more that we're going to look at in the next video. It's that Math Magician, and I'll see you next time.